So in this chapter, we're going to go over sets, which are a member of the collection, superclass, just like lists are, and stacks and queues. So sets, unlike lists, they don't have any indices. They don't reveal the order in which you insert items. So in other words, order doesn't really matter. If you look at a set and look at the items in the set, you can't really tell what order they were inserted in or whether one is more important than the other. It's just a collection. Order doesn't matter. That's kind of the big overall theme here. Order doesn't matter for things that I'm discussing. We can do efficient search and retrieval information. So we're going to be doing constant time checking to see if something's in it, constant time removing, constant time adding, all sorts of fun operations in constant time. And maps, instead, we'll see they provide pairs. You insert. It's the same thing, but instead we'll see that we insert pairs of items, keys and values. So the set is, if you've taken your math concepts course, then you probably actually instinctively know what a set is, which is that it's a mathematical set, right? The same type you would kind of see a math teacher write on a board, right? Let me go ahead and actually write one on the board behind me right now. So let's go ahead and erase the scribbles that my son left. All right, so, right, we could say like set S is equal to, and then we'd have these curly braces here, mathematical notation to say that the set is A, B, C, right? That's the mathematical set, okay? Remember, the thing about sets is that it doesn't matter what order A, B, and C occur in, right? This is the same set if I were to do, let's do S1, S2 is equal to A1, A, C, B, right? And we'd say that these sets are equivalent, right? They have the same items in them, right? Order doesn't matter. If I moved B over here and A over here, still doesn't matter. And this kind of doesn't actually make any sense, right? Having two A's in there, but because that kind of just reduces down to the same as having one A in there, right? Items only occur in a set once. Either you're a member of a set or you're not a member of a set, right? And we can use that same notation when we're describing the sets that we're programming too, because that's what these are. We're programming the mathematical set. So we can say stuff like, A is a member of S1, right? We can say S3 is a union of S1 and S2, right? We can do those kind of operations with sets, right? So that's the kind of, so hopefully you've taken a math concepts class and dealt with sets beforehand. If by some twist of fate you have not to worry, these are fairly straightforward. It just helps if you already know this stuff. Okay, so let's go back to the slides. All right, now as you see from this hierarchy, there are multiple ways to implement a set. We've got the hash set, which is the type that we're going to always assume we're working with when we're talking about sets. And hash sets, they deal with constant time operations, right? Constant time addition to a set, removal from a set, checking if something is in a set. But you can't assume anything about the order of the items you've placed in them, right? The items are going to be completely unordered, as we'll see. Tree sets, on the other hand, they are built using trees, so they do everything in log n time. But the idea is that they use a tree instead. So I find it actually better to just go ahead and start coding these things. So let's go ahead and start by coding public static void main, hit tab, right? Set of, let's go ahead and start with the set of strings, right? We'll need to import it. So go ahead and import it. Set of strings, set is equal to a new, right? And so set is an interface, so we're going to create a hash set. That will also need to be imported. Okay, so we've created a new set, and these operations are fairly straightforward. Set dot add. Let's go ahead, view, enter distraction free mode. Okay, set add hello, right? And we'll just go ahead and start by printing something out. We'll print out our set. Right, unsurprisingly, this is the operation that will add is the operation that will add this to the set. We can print it out just like that. Boom, that works just perfectly fine, right? Now let's go ahead and do set.add world. And notice that it is world hello, right? So you might think, okay, so it puts the newer thing in first. Let's go ahead and do set.add world, and we're going to go ahead and do set.add hello with a capital H, right? So now we've got hello. We've got hello added, we added world with an exclamation point, and we added hello with a capital letter. And there seems to be no rhyme or reason to where these items get placed, right? Each of these strings, there's no rhyme or reason to where any of these strings get placed. But we've run this program a couple times, the same exact program, and we do notice that they always do end up in the exact same order. It does appear to be random where these strings end up in our output. It's not, but for the sake of being able to, but for the sake of you using a hash set or a hash table, you should assume that essentially that items are essentially going to be in random places. All right, so that's adding an item, right? And so you can do the same with removing an item. Set.remove. We're going to remove hello from there, and we'll print out the set again to show that it's removed. Right? And if I wanted to see how big it was, I can use the size operator instead. Right? And it does the obvious thing. It prints out how many things are in the set. Right? We remove it, so now it's down to 3. So add, remove, right? And now finally we can use the other big one that you're probably going to use the most for using a set is contains, right? So now I've just removed hello with the capital H. Now I ask, does it have that? It will return false. But if I do it with the all lowercase hello, it's going to return true. Okay, and those are the basic operations you can do with a set, and you know they are fairly straightforward. That's essentially all. Those are essentially just about every single operation you're going to use a set on. Now, if you know mathematical sets, you know that there are different operations. There's union, there's intersect, right? There's check membership, right? And then there's set difference. So what about all those operations? Well, all those operations I'll go on in the next video. They're pretty short, but they just have different names. There is no set.union. There's a different name for it, which I'll go on in the next video. But the key thing, but these are all the key methods. Add, remove, contains. Those are the big ones. And since this is a hash set, we can assume that all these operations took constant time. They took O of 1 time with a big, nice, big, fat asterisk, right? Kind of assuming, basically assuming with assumptions that basically that the implementation of hash set is good, which we are normally able to assume. So that means that no matter how many items are in this, it takes no additional amount of time to add any item or remove any item or check. And it doesn't matter if there's 1 million items or 10 items. It should take around the same amount of time. It takes a constant amount of time, which is kind of fascinating. All right. So The next videos will be as follows. I will go over the other methods, and then I'm going to use, in the video following that, I'm going to use the hash set to solve a problem that was actually pretty tricky for us in homework 2. All right, so catch you on the next video.